going to uh, start our first 10-hour workshop on Topaz. So, I'm first presenting the plan of what we are going to do. So, is my screen visible to you?
Yes, I can see.
Okay, perfect. So, in this 10-hour first telling about myself, I hold I'm myself Baljit Saniwal, and these are my ResearchGate, Google Scholar, and YouTube channel links. And this is about me. I have experience in Monte Carlo simulations about more or less 7-8 years, and your supervisor Peter asked me, requested me to provide prepare a 10-hour workshop for you so that you can get started with your PhD work using Topaz Monte Carlo simulations. And we will be focusing more on brachytherapy problems that you will be working on in future experiments, in your future studies. So here I adapted one example of brachytherapy for this course, but there are many things that you can do with Topaz that we'll be discussing today later in this tutorial. So in the first day, like today, we already installed the Linux. So day one and two will be kind of mixed up because you already have a Linux installed in your system, and we'll discuss a little bit about Monte Carlo simulations using Topaz, and then we will try to do the installation in your system and understand the structure of how you define your different parameters to um, simulate any kind of study that you want to do, and and we will play with the examples, a few of the examples. Later, we'll be defining. I decided to uh, start this course with this simple geometry. There is iodine 125C, that is above is the lead shield to uh, shield the radiation that goes on the other side of the seed, and in the yellow is the mesh, and that is the voxelized water phantom of a zero point 0.3 millimeter voxel side length, and we will be depositing those that is emitted from iodine 125 source in this water phantom, and we will be analyzing it. So it is going to be a step-by-step process. First, we will discuss about the basics of geometry description, how you can define your own geometry, and then we will define our own geometry as shown in this setup. Next, we'll learn about how you can define different physics parameters, um, and we will continue in this day 5 and 6 the same thing. Then we will talk about different ways of scoring scoring means how you want to calculate the what you want to calculate, whether you want to calculate the central axis depth those, lateral axis depth those, or those color wash, or what kind of output you are expecting or want to get. So we'll work on that on day 8, and then day 9 and day 10 I have divided them into once we have the output. Now how we can access, or it's what we will be getting, it will be the dose deposited in the whole voxelized phantoms, but maybe we are just interested in the central axis depth dose or lateral axis depth dose, or just a color wash. So how are going to extract those such things using Python. So last 2 days I have allotted for this thing, and all the data or all the material that I will be presenting in this tutorial is taken from the official website of Topaz. Okay,
Mm. All right.
perfect. So, do you have any suggestion or comments about the plan, or anything you would like to say?
I think it's perfect. Yeah.
Okay, perfect. And just give me a sec. Oh, where is sorry for this interruption, but yeah, now back. So this is the official website of Topaz. Earlier, as I mentioned, it was not open source. You had to request for a user license, single user license, and then you can get and the kind of like you can get your license, and then you were allowed to use it. But now it's open source, so you can directly go to the download section and you can look for which version suits your operating system. Like for instance, you're using Ubuntu, so most probably the one you will be using will be Debian 9 part 1 and
Yeah.
part 2. And then when it comes to like how you install it, uh, I will be presenting this in the presentation, and there is a tutorial that I will share it with you. Steps are going to be more or less same. All you have to go do is just go to the user guides and then go to the installation guide. And once you are here, just look for Debian, and just copy paste these commands one by one, and it is pretty simple. And if you will follow these commands and the video I will share, the link I will share with you, you should be able to install Topaz and run some examples using it. Okay,
Okay.
perfect. And also, if you wish to be part of the Topaz community, you can go to this link and register yourself. This way you will be able to join the Google form of Topaz, where different users have different kind of questions or troubles that they are facing in their studies, and they you can directly ask those questions from the developers, and they generally reply back within a day or a few hours. So you can I think this is really very helpful sometimes. And there is maybe a bug, or sometimes it's like no other person knows much better than the devices or the tools that the developers have developed. So
Okay.
they are the best persons to answer your query, mainly in the
Okay.
advanced stages, not just right now, but in the advanced stages, you will definitely need their help.
Okay.
And also, apart from these 10-hour workshop, then after this, like, you know, initially you want to start from somewhere, and I think this 10-hour workshop will be really helpful to you. And after that, you can jump into this page of presentation and demos, and here you can one by one start looking, or maybe you can start looking from now, and you will get an idea like how you should design your simulations, how what are the functions of Topaz, and how you can efficiently use it. And yeah, that's it. So
Okay.
let me present today's presentation that I have prepared for to get you some idea more in detail about Topaz. So we are talking and going to be using Topaz, the Monte Carlo code, in our this 10-hour workshop, and its full form is Tool for Particle Simulations, and it is developed from by Slack, UCSF, and Harvard University, Boston, MGH, Massachusetts General Hospital, Boston. And now, what you can do with Topaz. So, using Topaz, you can perform almost all kind of simulations of your experiments that you do perform in clinic, like external beam, using particle photo, like proton, electron, carbon ion, also using photons. Then you can simulate your brachytherapy experiments. You can perform simulations using the CT images. Then you can perform all kind of like micro, nano, macro dosimetry, and there are different techniques by which you can optimize your simulation, like reduce its time. It is called variance reduction. Maybe we will not be touching this part in this workshop, but in later or advanced, I will plan for this. And there are other things as well that we'll see in this. Here basically I have collected some of the examples that are provided in Topaz, and that you should go and look in their parameter files to get an idea how you can work with Topaz. And I have also included one study as an example in this tutorial, which we already published in one article. So that is to calculate the radial dose from isotropic point source placed at the center of a sphere, and we calculated which is called the dose point kernel. So that I will be presenting now. So initially talking about the examples that Topaz provides, they have provided one of the like proton therapy unit simulations of one of the from Massachusetts General Hospital, IBA, uh, proton therapy unit they have simulated, and this example is present in Topaz. Then the another is from this um, from UCISF. So these two are on the proton therapy examples that they have provided, and this is you can see how in detail you can perform simulations. For instance, here Topaz developers have provided an example on IBA nozzle at MGH. Then you can also perform simulations on calculating single strand or double strand breaks on DNA structures. So this is a picture that I took from one of the studies that I was performing during my PhD. So these are like DNA strands or plasmids, and basically chromosomes with the and I was calculating the double strand breaks. So you can see how detailed or how much complex geometries are you can simulate using Topaz. You can even perform simulations on calculating the radiolysis or estimating the radiochemistry of radiolysis of water when you radiate water phantom with the radiation, how these ions are formed and what radiochemistry occurs. You can do that, and this is also a picture that I took from my own study that I performed on radiolysis of water. And for two, like now I showed you what are the capabilities of Topaz. Now the question is what you exactly need to know before you start learning or working with Topaz. So of course you don't need any kind of programming knowledge, and I mainly whatever you'll need at the initial step I will be providing in this to you in this 10-hour workshop. Also, like I initially in our first day discussion in the orientation, I mentioned that and these Monte Carlo codes work efficiently only on Linux systems. So that's why I insisted you to install the virtual machine and Ubuntu, which you already have done. So if you can just if whatever you want to search or want to do, you can just do the Google, or you can ask me. I will help you to just make a note of the basic commands of Linux, and that should be enough for you at the initial step.
Okay.
And yeah, this is it about the Topaz capabilities. So now coming to how a parameter file of Topaz looks like. For instance, here it is also an example given in Topaz, simple example where the developers have provided a code like how you can define just a single box. It is kind of like just single box is kind of useless, but it's just to good enough to get started. So you can get to know how you define your geometry, that is the box, how you define your physics. Physics means how you expect the particles to interact, like you will need different kind of physics list for your high energy or radiation simulations. For instance, if you are working with 6 MV photon beam, you need a different kind of physics list or different kind of physics parameters than if you are working on diagnostic x-rays. It requires different parameter settings, similar physics parameter setting. Similarly, when you are doing brachytherapy, it requires another different set of physics parameters. So the main idea is generally what I personally do is I do a literature review and try to find out what other researchers have already used, and I try to adapt that system. Maybe they are using different Monte Carlo code, but you can always translate it to Topaz, and this way you can do your simulations effectively. And physics list is something that has a huge impact on the output that you will get from your simulations.
Okay.
So here it's a small box. So if you see closely, it defines, it's a simplest Topaz example, and it defines a box in a beam of with electromagnetic physics. So if you see the geometry definition, you see so it's Topaz parameters or definition is more strongly binded with the how to say data types. So you see when you write any kind of uh, word like this tst box, it's in C++ language, it is called a string. So s means string. So wherever you'll see anything in double quotes, or you whenever you try to define any name, you should add a string if it is so. And when you have like point in your uh, measurements, like here is 2.5 meters, so, and which is the length along the x-axis for this box. So it is like if it has a decimal point, it is double, and if it doesn't have a decimal point, then you put I for integer. So, and here they have like define box with a half length along x-axis is 2.5 meter, y-axis it's 2 meter, and z-axis is 1 meter. And it's translated. So basically here there is another concept of a world that I will be explaining you in the future slides, or maybe in the next tutorials. But you can consider world as an environment. For instance, if you are working in a hospital, in a treatment room, and performing your experiments, so the treatment room is your world. And this whatever setup, like for instance brachytherapy machine, that is going to be your main box or main experimental setup. So this my box is basically your name that you want to define or give it to your experimental setup, and this world is outside the surrounding that you are working on. So I will provide you in more details on this world concept, but for now I think it is For now, you can skip this one. And so basically, for this